Okay, so as we talk about finding lengths of chords and radius and all those other kinds of things, the first one says, if you have two minor arcs, they are congruent if and only if their corresponding chords are congruent. That makes sense. Like if this chord and this chord is congruent, if they're the same size, that means that the two arcs are the same size. Makes sense. The arcs around them are the same, the chords are the same. Okay? That's what that one says. The next one says, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, here's the diameter, and here's a chord. If that chord is perpendicular, and it'll either tell you perpendicular or you'll see that little box, then this chord bisects the diameter. Bisects means that the two sides are the same. So what that's saying is, if the picture looks like this and you have a diameter and a chord and they're perpendicular, these two parts right here are the same length. Okay? And so that's what it says right here. Those two parts are the same length. Well, if the parts are the same length, that also tells you that the arcs are the same length. Okay? All right, next. Perpendicular chord, bisector, converse. So it's almost sort of the opposite of this one. If one chord of a circle is a perpendicular bisector, then the first chord was a diameter. So it's just saying the other way around, if we know these are the same, that must have been a diameter. The only way that that could happen, where these sides are the same and that's perpendicular, is if that's a diameter. Okay? And then the last one here before we look at some problems, equidistant chord theorem. It says that if you have a circle and two chords are congruent, if and only if they are equidistant from the center. What it's saying is that AB and CD can only be the same size if I can draw a little line from the center to both of them and make them perpendicular. That little line from the center is measuring the distance from the center, and these two distances have to be the same in order for the two chords to be the same. So when you're trying to figure out, are the chords the same, you're just going to try to see if those two little distances are the same. Okay? Alright, that was a bunch of words and pictures. Let's talk about how you use them, because I think that part will help make it all make more sense. So, number one here, we're using this picture. It tells me that the measure of AB is 110. Now, in both of these, we're using the same diagram. So I think I'm going to draw this diagram for one. That way we'll have two pictures to look at. So I'm just going to draw that diagram. That way when I start writing on it, we won't get confused about whether we're doing the A part or the B part, or the number 1 and number 2. We'll let this one be number 1, and we'll let this one be number 2. Okay? So it tells me that the measure of the arc AB is 110. So I know that this right here is 110. It says for me to find the measure of BC. So it wants me to find the measure of this arc. Okay? Well, here's what I notice. I see that the two chords are the same. You see those two chords? They both have 9 on them. Well, because both of those chords have 9, that means that the arcs are the same. So the measure of BC is also 110. So not really a lot to do, but just to recognize that because the chords are the same, the arcs are the same. Okay, next it says the measure of arc AC is 150. So I know that this right here is 150. And it wants me to find the measure of AB. Okay, again, I know that arc and this arc are the same. If I add the whole entire circle together, that's 360, right? If I subtract 360 and 150, see what we get. 360 minus 150. I got 210. Well, 210 is not the answer, but 210 is these two parts put together. So how can I find the parts separately? If I know that they're the same and I know that together they add to 210. What if I divide it by 2? See, the whole thing was 360. This part was 150. So if I subtract 360 and 150, I get 210. 210 are these two parts together. I know that the two parts are the same, so if I divide them by 2, I get those two parts separately. Alright, let's look at a couple more. So this one says for me to find the measure, or the CE, so it just wants to know the length of this side. Okay? Here's what I can tell, or here's what I can notice. I can notice that this is perpendicular. Okay? So I know that whenever it's perpendicular like that, and that's a chord and this is a diameter, if that's 5, that right there is also 5. Well, that means that if I want to find CE, then I know if that's 5 and that's 5, what's CE? 10. Because that's just the whole side there. Okay, next it wants me to find the arc C to E. Okay, now that's not 180. And so this part right here would be the 180. B to D is 180. Okay, so what that means is that this one and this one are going to have to be the same. Okay, so what I'm going to have to do is I'm going to take 9x and I'm going to set it equal to 80 minus x. Because I know that those two arcs are going to be the same. Alright, add x on both sides, so I get 10x equals 80. Divide by 10, so x is 8. Now, unfortunately, that's not the final answer, because the answer said for me to find CE, which means it wanted me to see what that whole arc was. Okay? If x is 8, this part of the arc is 72. Right? So I know that this part right here is 72. Well, if that's 72, I'm going to multiply by 2 to get both of them. So 72 times 2 is 144. And you get 144 degrees. Okay, so what I think is easiest is to figure out that WX first. So I know this is 42. That means this is 42. And then that means the arc is going to also be the same. So the arc is also 42. Okay? Now, this is 42, and this is 42. Okay? Now, before we get the sides, let's talk about the rest of the angle. So if that's 42, I can figure out this angle right here by subtracting from 180. So I can do 180 minus 42, which is 138. And if that angle is 138, that means the arc is 138. And then I can do the same thing over here. I can do 180 minus 42 to get this angle. It's also 138. So that's 138. So when I come down here to this arc, XY, I know that that's also 138. And both of these are degrees. Now after we get the arcs, then to find the sides, I think finding the sides are easy after you know that the arcs are equal. If the arcs are equal, that means the sides or the chords are also equal. Okay? So YZ is just going to equal that chord that's up there, so I know that's 3.6. And then WZ is going to equal this chord here, which is 9.2. And all of that is true because the arcs are the same. Alright, so the next few, they're all like pictures of what we know is true based on some of those theorems that were at the top. And so if this is 8, and this is perpendicular, I know it's a bisector, so what's x? 8. It's the same, because that's what a perpendicular bisector does. Let's skip on over to number 10. Okay? So it's telling me that this arc is this, and this other arc is this. So what I do is I try to set those two things equal to each other to try to find the arcs. So I take 5x plus 2, and I set it equal to 7x minus 12. And then I solve, because I know if it's a perpendicular bisector, the arcs are the same. So I'm going to subtract 5x on both sides. I'm going to add 12 on both sides, and divide by 2. Okay, so number 8, again, it's that perpendicular bisector, and I know that these two sides are the same, so that means that the arcs across from them are also the same. So this one is pretty easy. We know that x equals 40 degrees. Alright, number 9, still a perpendicular bisector kind of thing, and we have these two sides right here. That just means that the two sides are equal, so we just have an equation that we need to solve. Subtract 2x on both sides. Add 6 on both sides. Divide by 3. And we have our answer. Okay? Alright, so let's look at it, and if it's not that type, still a perpendicular bisector, but this time it wants us to find the radius. I would say that these two problems are probably the most involved kind of problems, but still similar to what we just talked about. Okay? So, it's asking us to find the radius. They already gave us 3 right here. Okay, that's not the radius though, because there's an extra little piece. Does that make sense? For it to be the radius, it has to go from the center all the way to the other side, and that doesn't do that. We can actually draw a radius from the center to C, and then right there is what we're looking for. Okay? Well, for us to find it, we're going to use the Pythagorean theorem, because this is a 90-degree angle. Okay? We know that this is 3, and if we can find this part right here, we can use Pythagorean theorem to find r. Okay? So what we're going to do first, we're going to go ahead and set these two things equal to each other so that we can find x. So 5x minus 2 is 3x plus 2. Okay? Trying to get x by itself, so I'm going to subtract 3x on both sides. Then I'm going to add 2. Then I'm going to divide by 2. Okay, so x is 2. Well, let's see what that gives us. If I plug in 2 for x up here, 5 times 2 minus 2, that's 10 minus 2, which is 8. What that tells me is that whole side is 8. Does that help me find the other side of the right triangle? It does, because if the whole side is 8, and that's perpendicular right there, I know that this part right here is 4. So then we're just going to do Pythagorean theorem, and we're going to do 3 squared plus 4 squared equals r squared. So add that together, you get 25. Take the square root, and you get 5, and 5 is r, which is what it was asking us for. Alright, again we want to find the radius. So we're looking for this part right here. Okay, they give us that 20. 20 is that whole side. So I know that part of the side is 10. because of that perpendicular part. So next, I'm going to set these equal to each other so I could try to find this side. So I'm going to take 4x minus 5, equal that to x plus 4. Subtract x. Add 5. Divide by 3. Now I know that x is 3. So if I'm trying to find whichever part is easier, it doesn't matter. I'm going to take the 3 and plug it in for x. So 4 times 3 minus 5, so that's 12 minus 5, which is 7. So now I know that that side right there is 7. And now I'm just going to do Pythagorean theorem to find r. So we'll have 10 squared plus 7 squared equals r squared. Okay? So we'll add 10 squared plus 7 squared. You get 149. We take the square root of 149, and we get 12.2. So we've seen a picture like this before, but when we did this before, we were trying to find angles and arcs. And we added the arcs together and multiplied by half so that we could figure out the angle. But that's different here because this one is talking about finding the sides. Okay? And here's what it says. If I want to find the sides, then I'm going to take one part of the chord and multiply it by the other part of the chord. That's what that right there says. Multiply the two parts of the chord together. Then I'm going to take the other chord and multiply its two parts together. Those two things have to equal each other. Okay? So here's how that works in a problem. So we've got this chord and this chord. So you take one chord and multiply it, so 3x. Then you take another chord, 4 times 6. Then you solve for x, divide by 3, so you get x is 8. So as long as you recognize that that's what you do, the problem isn't too difficult, but basically that's what we have to do on these. We take one chord and multiply the two parts to the chord, and then we take the other chord and multiply the two parts of that chord. Okay? So if I'm going to do this one, I'm going to do 2 times x plus 1. Be really careful when you do that. Make sure that you multiply the 2 times both parts. And then you do these two parts together. So 2 times that part, and then 3 times 4. Okay? When you multiply that, you do have to do the distributive property. So 2x plus 2 equals 12. Subtract 2 on both sides. Divide by 5. Divide by 2, I'm sorry. And then so we get what x is. Okay, so we multiply the 10 and the 7x together. So that's 70x. And then you multiply these two together. Just make sure that you do 15 times that and 15 times that. So 15 times 5 is that 75? And then 15 times 2 is 30. And then at that point, then we just get our x's together and solve. So, oops. Subtract 75x on both sides. And then divide by -5. So x is 6. So here's another formula. And the difference in these three formulas have to do with the picture. Okay? If you'll notice the first picture, everything was inside the circle. And so that's when you do what we just did. Okay? If everything is not inside the circle, so if it looks almost like the party hat, except the lines are not outside the circle. So we've got this thing on the outside. Here's what it says, and so it's just a tad bit different. Okay? It says that you multiply EA, it says by EB. So you multiply the whole side by the part that's outside the circle. Okay? And then, same thing over here, you multiply the part outside the circle by the whole side. Okay? So instead of just the two parts like we just did, you got to think about the whole side now. Okay? So let's look at number 5. So here's the part outside the circle, so I know it's going to be 9 times something. The whole side would be 9 plus 11. So the whole side is 20. Okay? We need to do the same thing over here. So here's the part outside. And let's think about the whole side. The whole side is 10 plus x. Okay, so here's how we set it up. We take the short, or the part outside, multiply it by the whole side, set it equal to the part outside, multiplied by the whole side. Alright, multiply 9 times 20, multiply 10 by both parts, subtract 100 on both sides, divide by 10, and you get x is 8. Easier, a little bit easier because it's not quite as big of an equation, but same kind of problem. So first thing I want to do is find the whole side, that's 15, and find the whole side here, x plus 5. So take the part outside, multiply by the whole side. Take the part outside, multiply by the whole side. And then we just solve. So 6 times 15, I think is 90. Multiply 5 by both things. Subtract 25. So 90 minus 25 is 65. Divide by 5. And you get 13. Alright, last example of this particular kind. I just want to show you that. It does have x's on both sides, so it looks a little bit harder. Same kind of problem. I still want to figure out the whole side. So the whole side is 4 plus 2x. And then I want to figure out the whole side here. 3 plus 3x plus 1. Okay. So then when I set it up, I'm going to take the part outside, multiply by the whole side, the part outside, multiply by the whole side. I'm going to go ahead and add that together when I write it down, just to make it a little bit less things to have to write. Now I'm going to do distributive property on both. So 4 times both things, so 16 plus 8x. 3 times both things, 9x plus 12. Subtract 12, subtract 8x, and you get x is 4. Alright, so very similar to the others. This is outside, but notice this is a tangent. Okay, so it's not like there's a part inside the circle to get the whole side. So here's what you do. You still take the part outside and multiply by the whole thing. But the tangent part, the part that's tangent, you square it. Since there's not a part to like get the whole thing, what you do is you square it. Okay, so let's look at it on this problem here. So I still take the part outside and I find the whole thing, which is x plus 8. And I multiply that together, so I'm going to multiply x times x plus 8. And then for the part of the tangent, you put 16 squared. Because there's nothing to multiply it by, so instead we square it. Alright, this is a weird one, but I'm going to show it to you anyway. So you do x times both things, so you get x squared plus 8x, and then you do 16 squared, which is 256. Now, the problems that I'm going to actually give you to practice will not look like this at all. Okay? You won't have one quite as complicated as this on the practice that I'm going to give you. But I'm going to just show you real quick what you would do to solve it. You subtract 256, and then you graph it in Desmos. So you put x squared plus 8x minus 256, and you look for where it crosses the x-axis. In this case, we got a negative number and a positive number. And so what that means is that our answer is the positive one, because we're talking about a length of a side. And so since we're talking about the length of a side, we can't have a negative number. So 12.492 would be our answer. So anytime you end up with something like that that's a quadratic, you would graph it to solve it. You won't have to do that on the practice that you're going to be doing, but that's the process in case you ever see anything like it again. So let's look at number 9. Okay? So the x is the part that doesn't have anything else with it, so that's the part that will be squared. And then on this one, we've got the part outside and the whole thing. The whole thing is 4. So you're going to do 1 times 4. So you get x squared is 4. To solve that, it's kind of tricky, but what you do is you take the square root on both sides. It can't be a negative, so it's always just whatever this positive square root of that number would be. Okay, let's look at number 10. Okay, the part outside, or the tangent part, that's the part that will be squared. Here's our x, and here's our x plus 10. So it's going to be x times x plus 10. This one does come out similarly to number 8, and we'll go ahead and do it, but just keep in mind that the one you'll have will not be quite so difficult. X multiplies by that. And again, I'm going to go to Desmos, and I'm going to subtract 144 to figure out the answer. So x squared plus 10x minus 144. There's our zeros. We don't want the negative. We want the positive, so our answer must be 8. All right, last one. The part on the tangent, you square it, so 7 squared. All right, the whole side is x plus 5. So it's going to be the part outside times the whole side. This one comes out really nicely. This is a good one. 7 squared is 49. 5 times each of those is 5x plus 25. You're going to subtract 25 on both sides. And then divide by 5. We're going to get a decimal, and that's okay. So we get 4.8.